Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Muhammad FATHUL bin AMIR. My monthly number is 212020731. Alright, today I want to present about the DC motor and operations. Okay, for introduction, any rotary electrical motor that transform direct current, electrical energy into mechanical energy is referred to as a DC motor. Right, the most popular varieties rely on magnetic field to create force. Almost all DC motors contain an internal mechanism, either electromechanical or electronic, that change the direction of current in a section of the motor on a regular basis. Okay, next, part and design. Number one is branch. Branch, which the commutator are working as a bridge to connect the static electrical circuit to the rotor. Number two is DC motor commutator. The commutator is a split made up of copper segment. Commutator is another DC motor part. Number three is armature windings. The armature windings of the DC motor has two construction: lap winding and wave winding. Number four, it is rotor. The dynamic part of a DC motor is the rotor that create the mechanical rotation of the unit. And number five is field windings. Okay, it is made with copper wire. The field winding circle around the slot carried by the pole show. Number six is yoke. Yoke is a magnetic frame made of cast iron or sometimes steel, which work as a protector. Okay, and number seven is pole. Pole has two parts: the pole core and the pole shoe. These two parts are fixed together by hydraulic pressure and are attached to the yoke. At the last, it is starter. The starter is the DC motor part that receive the supply. Okay, next, operation. A DC motor is a type of electric motor that transform electrical energy into mechanical energy. The DC motor primary operating concept is that anytime a current carrying conductor enters the magnetic field, it is subjected to a mechanical force. After that, all conductor in the north pole carry current in one direction, whereas all conductor in the south pole carry current in the other way. Okay, next, the armature conductor under the N pole carry current into the plane of the paper. Conductor beneath the S pole on the other hand convey current away from the paper's plane. Okay, because its armature conductor is carrying current and is in the magnetic field, it is subjected to a mechanical force. So by using Fleming's left hand rule, it is clear that the armature is rotating anti-clockwise due to the stress on its conductor. All of this force combine to provide a driving torque that rotate the armature. When a conductor goes from one side of a brush to the other, the current in it is reversed. At the same time, the next pole, which is polarized in the other way, has an impact. As a result, the force acting on the conductor remains unchanged. The force acting on the conductor remain unchanged. Okay, for the last, it is words mention that a commutator in a motor perform the same job as a generator by reverse current in its conductor as it goes from one pole to another. It aids in the production of a continuous and unidirectional torque. Okay, that's all from me. Amir, can you continue?
Next, we got a type of DC motor. First, permanent magnet DC motor. A permanent magnet DC motor, or we call it a PMDC, is a type of DC motor that use permanent magnet to create the magnetic field that required for the operation of DC motor. Third, we got a shunt DC motor. Shunt DC motor, also known as a shunt wound DC motor, is a type of self-excited DC motor where the field windings are shunted to or are connected in parallel to the armature winding of the motor. Since they are connected in parallel, the armature and field winding are exposed to the same supply voltage. And last, we got compound DC motor. Compound DC motor is compound of both series and shunt motor. It is consists of a series field coil which is connected in series with the armature field winding, and shunt field coil winding is connected in parallel with armature field winding. Last, we got compound DC motor. Compound DC motor is compound of both series and shunt motor. It is consists of a series field coil which is connected in series with the armature field winding, and shunt field coil winding is connected in parallel with armature. There are three ways to control the speed in DC motor. First, by varying the flux and varying the current through field winding. Second, varying the armature voltage and armature resistance. Third, through the supply voltage. Last part, we got starting method. Starting method is the most common type of starting technique that to reduce the voltage at the starting of the motor and to reduce the inrush current that could damage the winding of the motor and also cause the huge dip in voltage. First, we got a star delta starter. A star delta starter is the most commonly used method for the starting of a three-phase induction motor. In star delta starting, an induction motor is connected through a star connection throughout the starting period. Then, once the motor reaches the required speed, the motor is connected in a true delta connection. Second, we got a starter through the data that we collect. We can conclude the armature which rotates is called the armature and the field coil, which is fixed and comprise the wire coil, is called the field coil. The starter is the name of stationary portion. The armature is formed of a coil of wire coiled around the core, and the core has an extension shaft that spins on the bearing, as shown in a figure. The commutator is the place where the brush make electrical contact to transport the electric current from the fixed component of the machine to revolving part. That's all for me. Thank you.